pin the video so that it is seen by you.
Okay, I have started the video. So we want to welcome everyone that is joining this call. Thank you so much for joining in. We are going to start our session at exactly past. But we want to ask you to have your videos on. Probably you can take us.
What are you saying? Are you seeing yourself in the picture? You're seeing my hand.
Okay, thank you, Mr. Ronald, for taking us around.
So those are going to show you.
Coming out. The audio.
So we want to welcome all the schools that are joining. Thank you so much for joining. I am kindly that you can have your videos on. Feel free to turn on your video such that at least we can see where you are joining in from. Kindly have your videos on such that you can see where you are joining in from. Otherwise, we are really very grateful. Thank you. Okay, that is Mr. Torome. You are most welcome. Okay, you're most welcome, Mr. Torome. Can you talk to us? Your microphone is muted, Mr. Torome.
Thank you, colleagues, for allowing me in this meeting.
The camera is not okay, so I'm not going to turn on my video.
Mr. Ray.
I'm sorry, I mean, attend to you later.
Okay.
Mr. Torome, go on.
Yeah, I'm saying I'm very happy to be part of this meeting this evening. I can see it is for how many days? 3 days, 4 days. However, I've seen that it is both for A and the O level, and it has different links. I would wish to attend both. I don't know how possible is that.
Oh, okay. Which one are you interested in?
I wanted to attend both. I'm interested in both, but I've seen they are at the same time because it will be very useful.
Okay. Okay, sorry. But all of them are, I don't know how you can, but maybe one, you join using 2 gadgets.
Okay.
Zoom model.
So we are waiting for the rest to join in, and then we shall get started at exactly past.
Tengo.
We want to welcome all the schools that are joining in. Thank you so much for joining. Our session is going to start in a few minutes from now. We are going to start with something briefly because our target is to ensure that the schools can be in position to save as much data as possible. So allow me to welcome Brenda to talk to us briefly about how we are going to be, how we can save data using the big blue button. Over to you, Brenda. You are most welcome. I'm going to mute everyone such that we don't have any background. Brenda?
Yes, thank you. I am Brenda Namoni, Systems and Software Engineer from the Research and Education Network for Uganda. So I'll just take you through how to use the Big Blue Button platform and how you can utilize it. If you have any other expectations, you let me know.
Brenda, you are muted. Brenda, you're muted.
Yes, Stephen. I'm loading the platform on my end. Do I have sharing right?
Yes, you do.
Okay. So I will just share the platform that we can use at Reno, and I'll use that for demo purposes. Are you able to see my screen?
Yes, your screen is on.
Okay, so Stephen, I still able to hear me?
Yes, we can.
And you can see my screen?
Yes, we can see homeroom, 26 sessions. We have lost you.
Okay, so ideally this is how the platform would look like when you've logged in. Let me first log out to just show you how it should be. So if there is a platform, it should look something like this. So this just gives you like a summary of the features. If you want to watch a tutorial on this as well, you can always click on that link. And on sign in, so according to the institution's platform, they have different login methods. Oh my God, Zoom keeps logging me out. Stephen, I still able to hear me?
Brenda, we want to know. Brenda, we want to know whether we can use the big blue button without paying. Is it zero rated or it's not zero rated now?
Pardon? So Stephen, I keep getting kicked off the network. Hello?
Hello, sorry about that.
Yeah, I keep getting kicked off the room. So
Okay, maybe briefly just share with us the advantages of the big blue button.
Can we access the big blue button without paying?
yes, so I think Mr. Dung was asking whether the platform is still zero rated. Yes, it still is. The advantages, first of all, oh my God. So I think we all know that I'm getting off again.
Maybe Stephen, you just share.
We want to welcome all the schools that are joining. Thank you so much for joining. This is our first session for physics that is going to start off the 2 weeks of facilitation. We want to thank all the schools that are joining, and let me ask a volunteer from one of the schools to raise up their hand, and then you take us through a word of prayer. Any volunteer from any school or any school that is willing to lead us in a word of prayer, kindly raise up your hand. Okay, Charlotte. Thank you, Charlotte. Share with us your school, and then you lead us. Charlotte, unmute. Unmute. Okay, I think we are failing to get Charlotte. Esther, come back. Teacher Esther, yes, let the student come back. Unmute. Okay.
I begin.
Yes,
And let's
begin.
have also what is here. Those my pattern, which is what you can take a thing that is being taught. I assume it will but are not all the schools that are going to concentrate on this is that's going to be taught. This is the name of it for me.
Okay, thank you. Kindly share with us your school's name.
First of all, my name is Chapas, and I'm from Akta School.
Okay, thank you. Thank you so much. We want to welcome all the teachers that have joined our call. Thank you so much for joining, and all the schools that are joining in from the different parts of the country. I want to call on and I give 2 minutes to Brenda to briefly talk to us about the big blue button, because it is very, very expensive for schools to buy data every time. So we want to see what Trend has for us when it comes to the zero-rated big blue button. Brenda, over to you to summarize for us, and then maybe next time we shall try out on what we can do to access that platform.
All right, thank you, Stephen. Are you able to hear me now?
Yes, you're clear.
Okay, so maybe just to give a brief, so Big Blue Button was the aim of the platform was to engage educators with and also give a platform to students to interact with these educators. So it was basically designed with education in mind. And what Renu did was to host the Big Blue Button platform on our end so that we can offer this service for free at up to a certain extent anyway, but for free to all our members, so that if someone approaches us, they can get a total of 5 free accounts on the Renu Shared Big Blue Button platform. And this will allow them, so the whole point, if you have the platform, you can integrate it with your learning management system if there is one in place, so that if students are to maybe attend classes online, it is directly integrated into the LMS and they can get all that information from the learning management system. Then, of course, the platform is zero-rated, which means that you won't need data to access it, or even the students will not need data to actually use the platform. So it has different options of sharing material while the sessions are happening. Students can interact with each other. They can also interact with the lecturers. And so even on the platform, let's say you want maybe a lecture is happening and you want a student to solve something as other students are also observing, there is something called like a whiteboard, which gives you that, like it gives you the ability to actually allow that as the student is trying to do something, other students are also able to see what is happening. So of course, with that, you get so many features. There is sharing of video, just to monitor what your students are doing, if everyone is attending class as they're saying that they are. I think that's mostly what you would get with the platform. So it provides you with that interaction, like how it would be if you were in a classroom.
Thank you so much, Brenda, for that brief view about the platform. I know one time we are going to try it whereby we shall have all schools connected without use of data, and we see how it runs. Thank you. Okay, allow me now to invite Mr. Ronald Dungu from the Ministry of Education to say something and to officially open this session. Mr. Ronald, you're welcome.
Mr. Kaziba, I don't know how successful I will be, because I mean, crossed from Germany, across the Nile to Obongi district, and I'm driving to Koboko. I'll spend the night in Koboko and then I'll see tomorrow. But what I've done is to test and see whether I can be heard, whether I can hear you. Means that even children in this place who are looking after the cattle, I'm passing children looking after cattle, they cannot be in school. It means that we can arrange an education where we can close the learning gap with even the pastoralists in these areas. So that is why we are on this call to try and see if we can close the learning gap. And I'm happy that the schools are joining us today to start off to hear from you at some point, whether it was beneficial, but also whether you were able to connect through and your internet was not a problem. So working with the Research Education Network Uganda, Renew, accelerated, and therefore schools and teachers can connect freely, which would enhance education. So I'm excited that at least we have started. And I also want to report that I was on the ferry for this crossing. They can be able to connect to the rest of us.
Mr. Ronald, I think we have lost you. Sorry about that, but I know we shall get him back at one point. Okay, so he was telling us that he's in Koboko, he's crossing the Nile.
River to tell us. Mr. Kaziba, I think I'm losing the network midway. So I want to say that this session is officially open.
Oh. Okay. We are losing him, but thank you so much, Mr. Ronald Dungu, for those remarks. I think now we are going to dive deep into our session. Today in our session, we are going to be dealing with paper 1 and paper 2. Then I want to request the students, have your pen, have your paper, or have your book where you are going to write, and then we shall have a lot to learn from the session. In case you have any questions, you can have those questions put in the chat, and then later on, we can have them answered. Allow me now to call on. I want to just check whether I have Teacher Nyangu. Are you on the call? Teacher Nyang? Kindly just let me know whether Teacher Nyangu you're on the call. Okay. I'm failing to get Teacher Nyangu, but it is okay. I want to welcome Teacher Peter Nsubuga to take us through the presentation. Teacher Peter, you are most welcome.
Okay, Mr. Kaziba, good evening. I hope you getting me well. I'm sorry.
Okay, your voice is a bit low.
Are you getting me now?
You are improving.
I think it's probably my headsets, but I think we will move on from there.
Okay, better.
It all is well. I'm sorry, in the background there is some DIT class for music instruments taking place, so it may disturb us a little, but hope the students can get me well wherever they are. My name is Peter Nsubuga, teacher of physics at Wampe Ontake Secondary School. This is in Wachiso District along Gayaza Road. I welcome you all to this session wherever you are tuning in from, our dear participants. Today in our session, we are going to be discussing physics, paper 1 and paper 2, especially how we answer these questions and how well we can excel in these papers so as to enjoy our physics. Please let me know in the chat if you are receiving my voice as well, so that I can be sure that we are communicating properly, and this will help me as the session goes on. Okay, Umboni College dealer tells me that they can hear me well. Thank you. So I'm going to share my screen and we'll start from there. Our discussion or our facilitation. Yes, today is today is 24th of July 2023. This is our physics facilitation, and I'm going to be a facilitator for today. Teacher Peter Suvuga, my name is. So before we go any further, I want to take you through the topics that are examined in physics and in physics papers. In physics, we usually study about mechanics. That is the first topic, from measurements, forces, moments, pressure, properties of matter, motion, and so on. Those ones lie under mechanics. Then we have heat, optics, and in optics we look at the light and the waves. Then we have electricity and magnetism. Then lastly, we have modern physics, which is divided into atomic and nuclear physics. Probably as they are setting our papers, they set from all those different sections. Paper 1, we have 40 objectives, and then we have 40 objectives in section A, and then section B we usually have 10 questions which are structured. Structured questions mean that these people need short answers to those questions, and each of those 10 questions carries 4 marks. That means section A will give us 40 marks, and also section B will give us 40 marks in our paper 1. Then in paper 2, we have 8 questions from all those sections. Mechanics carries more questions than any of the questions, any of these other topics. 1, 2, 3, 4, 5, 6. Mechanics will take 2 questions in paper 2, and then the others will take 1 question each. And this one leads us to 8 questions, where we have to only choose 5 questions which you can answer best are the ones that we choose in paper 2. Now our paper codes for physics. Physics 1, the paper code is 535/1, whereas physics 2, the paper code is 535 paper 2. I will not talk about the practical because this session is specifically designed for paper 1 and paper 2. As I was telling you, the structure for paper 1, we have 40 multiple choice questions, and then the 10 questions where they want us to give short answers or short replies, or replies that must be short and precise. Whereas for paper 2, we have extended responses, which we call essays. Now, extended responses have explanations, have description of experiments, and this one is examined mostly in paper 2. So let us start with paper 1. If I want to pass, or if I wish to pass my paper 1, what are the things that can help me after I've read my content well and I'm safe and secure that I can go in a paper and answer? What are the hints that can help me excel in my paper 1? Now, the first thing that you should note, my dear candidates, that you should never leave an objective which is unanswered. Please never leave an objective unanswered. However difficult it is, we are going to see how we can use basic skills and we get those objectives that we think are difficult, we get them answered. So never leave any objective unanswered. So what are these hints that we can use so as to have our objectives answered? First of all, you have to read questions carefully and you identify which key concepts are these people talking about. Which key concepts are being examined? What do these people want from you? What does the question expect from you? And you also read about the variables that are mentioned. For example, if you are to answer a calculation question, you must know which variables have been given, and then how are you going to use them so as to get the answer that you are required to get. So reading questions and identifying those key concepts and variables is so important as we are doing paper 1. Then the other hint I can give you is we have to think logically. Thinking logically means you are given a question, you have read it properly, you have identified the key concept or variable, and then you need to start applying laws or principles or relative concepts. For example, you may be required to answer a question maybe that requires you to know the principle of moments or of law of conservation of momentum. So you should know, how is this law applied? How is this principle applied? How does this concept lead me to my answer? So you must think about those things as you start reading. Now, after I've thought logically about the principles and laws and relevant concepts, there is a trick that you can use. Maybe you are not sure of the correct answer, you are still having 2 or 3 options in your head. What you do is you start eliminating those ones which are obviously incorrect. They are those ones which are not anywhere close to the answer that you are supposed to write. First, eliminate those ones. Now, as you eliminate those ones, this increases your probability or your chance of choosing which objective is correct. So you first eliminate those ones which are obviously wrong or obviously incorrect. You'll find out that you are remaining with maybe 2 or even 1 objective, which will be your answer. Okay, we continue. Then if I'm to look at the calculations calculations in objective questions can only be got if you know the formula or the equations or the principle that you have to follow. So what you have to do is to make correct substitutions. Make correct substitutions of those into those equations. For example, if you are given a question which requires you to get force, but they gave you mass in grams, you know that to get force, I must have mass in kilograms, and I should also know that force is equal to mass times acceleration due to gravity. Acceleration due to gravity is given always on our papers as 10 meters per second squared. Then mass has to be in kilograms. So it is you, the candidate, to know that I must get this mass, which is in grams, change it to kilograms, and I then substitute it into my equation. So correct substitution is key if we are answering calculation questions. Then next is section B, the one for structure. Structured questions in section B only require answers which are short and precise. In other words, they have to be on point. They should be short and precise. When they ask you to state a law, state that law. When they ask you to give an example, give that example. If they ask you to define, give that definition. For example, if they ask us, define the term pressure. We don't want you to start that pressure is defined as that is wasting time. You have to start, if they say define pressure, you start pressure is force acting normally per unit area. Okay? So you should be short, your answer should be short and precise. If they ask examples, maybe of electromagnetic waves, state them, gamma rays, X-rays. Don't start examples of these ones include. No, we don't want that type of answering when we are answering section B in paper 1. We should have short answers and precise answers. These hints that I've given you can briefly help you to answer your questions in paper 1 physics. If you have read your content properly. Yes, Mr. Kaziva, I request you to help me with the hands. Don't have a co-teacher around, so if you are still there.
I think the person is not hearing. His microphone is off, so we cannot help.
Okay. Yes, I also ask that in case of any questions, you can send in the chat. We can pause some time and we answer some of these questions as the time goes on. Yes, we are going to start answering these questions that we have, and I'm going to give you sample answers or how I got to these answers such that we can learn how to answer
Teacher Peter. We have shared the questions in the chat. We have shared the questions in the chat. Mr. Onyango. Mr. Onyango. Stockholm.
Hello.
Yes, come in. As teacher Peter
Thank
gets.
you. Maybe first I share. Let me first share it.
So check in the chat, teachers. We have shared the questions that we are going to use as samples to help the children.
Yeah, thank you so much. A lot has already been said by my colleague. For us, we shall move on to where he has stopped. And that is, I think we are here. Eh?
Yes.
Here remembers?
Yes, Mr. Nyang, continue.
Yeah, was at the verge of coming out with what has come now here. When we try to see, we see that from question 1, the issue of thermoelectric or the hot filament means thermal, and definitely I believe the questions are shared. We'll find that the answer is C. Just by eliminating some options, when you move to radioactivity, is not an elimination of that. Nuclear fusion and photoelectric all are not the same case. Therefore, that is why the correct alternative there is C. But also from question 2, when we try to see that nuclear reaction, the nuclear reaction where the atomic number increases by 1 definitely is ejection of beta particles. And we look for the alternative where beta particle is. Definitely we find that by elimination, A stands as the correct alternative. Now, when we move to question 3, the half-life. When we move to question 3, the half-life, definitely we see that 4 minutes is the half-life and 24 minutes is the total time taken. When you divide 24 by 4, you will definitely get, what could that one be? I am here with the learners also, we are together in the class. 6. Now, when it is 6, it means when we go 64, 9.6, what is a half of 9.6? That is the first half-life. 4.8. The second half-life, half of 4.8, 2.4. The third half-life, 1.2. And the next half-life, 0.6. Have we divided correctly? 9.6 divided by 2. Because we need to go to 6 half-lives. What is 6 half-life? Please, let's divide. Let's divide together. 4.8 divided by 2 again. 2.4 divided by 8 by 2 again. 1.2 divided by 2 again. 0.6 divided by 2 again. 0.03 go to the last half life. 0.3 divided by 2. 0.15. So at the time of 24 minutes, we shall be left with 0.15 active particles, meaning the particles that have already decayed is 9.6 minus 0.15. Then from there, you will look for the alternative. He's saying 9.45 and 9.45 definitely is the alternative D. And that is how we go by the areas that require calculation. First of all, we are not gambling in alternatives or in section A of paper 1. We do it from the knowledge section of it. Then number 4, the function of the grid in the CRO, also by elimination. Also by elimination, we find that what is the function of the grid? From the question there, it is C. That is the correct one because that is the function of the grid. So definitely, that is how we have handled that section A. Then when we move to section B, yes, we are told we need to be very precise and straightforward, bearing in mind that we are time bound. So the atomic number we are asked to define. So it is the number of protons in the nucleus of an atom. Meanwhile, the mass number is the nucleon number, the sum of protons and neutrons that are in the nucleus. Then when we come to the B part of it, a radioactive particle is releasing 2 alpha particles and a gamma ray, bearing in mind that a gamma ray is an electromagnetic radiation and is only to stabilize the unstable isotope, but is not having any effect on the parent nucleus. Now that we have 2 alpha particles, when we have the alpha particle as being the helium atom of atomic mass 4 and atomic number 2, and they are 2, it means on the parent nucleus, 8 of the mass number will be removed and 4 of the atomic number will be removed. So 238 minus 8 is going to be 230. And 92 minus 4 is going to be 88. So this equation here must balance. The atomic mass must balance, the atomic number must balance. And that is why the equation is like that. Meanwhile, if there is any question, I believe you will post it on the chat and we shall get it later. When we come to number 6, beta particles. These are fast moving electrons of nuclear origin. These electrons are as a result of the nuclear reaction. The proton number is the number which is atomic number. And when a beta particle is released from a radioactive element, the parent nucleus is affected in such a way that the atomic number increases by 1. And the atomic mass remains the same. It's not disturbed. When we move to B, the calculation part of it, we still continue to do it as we have done in section A. Others can follow this procedure, which is simple, but others can also follow the procedure of dividing constant division by 2 as you get the number of half-lives, because from here the half-life is 24 days and it has taken 120 days. When you divide 120 days by 24, you get 5. So you continue with 64, the first time divide by 2, the second time again divide by 2, the third time divide up to 5 times, you will find that the atoms that remain radioactive by the end of the 20 days is 2 grams. We continue. Number 7, the A part of it. Radioactivity is a spontaneous decay or disintegration of an unstable nucleus to form a stable one with emission of radiations. And these radiations are the alpha particles, the beta particles, and the gamma rays. Now in the B part of it, a diagram is given for a radioactive element with the rays coming out, and the rays are subjected to move between the electric fields. You'll find that the beta particle, which is negatively charged because it is an electron, is going to be attracted to the positive terminal. And because it is very light, it is well deviated, very fast deviated. Then alpha particle is heavy, but also it is attracted towards the negative plate. But in the middle, that B is not affected by both the positive and the negative plates, meaning it has no charge, and therefore is the gamma rays. Hope we are moving together, Steve. Am I loud and clear? Hello?
You are clear.
Thank you. We move to the sample of that again, number 8. Nuclear fission is the process whereby a heavy and stable nucleus splits into 2 lighter nuclei with release of energy. These 2 lighter nuclei are almost having the same mass, not the same, but similar masses. The masses are not too different, not too far away from each other. One is not too heavier than the other. They are almost of the similar likeness so that they split. So how can we produce that? We can use a neutron to bombard at a very high speed to hit the nucleus of a radioactive nuclide or something which is to be split. Also, we can bring two light nuclei together. In addition to this, another alternative, you can bring two light nuclei where the sum of their masses will be slightly above the critical size or the critical mass. And when you talk about the critical mass, is the mass which can trigger reaction, which is chain reaction to occur. This is also one way of triggering or producing nuclear fission. And to account for the energy, why is this energy released during that split or separation? The energy has been released because that was the energy which was used to combine the nucleons together in the nucleus, the energy which is called the binding energy. So because they are splitting out, the binding energy can also be released. And one of the uses, we can use it to produce electricity, can use it to produce heat for metal refining, generation of hydrogen, and many others that can come with the development or the discovery. Part 2, the essay type of question. Normally, with UNEB, we set 8 questions, and all these questions are optional. All are optional. They require extended sort of response. You need to attempt any 5 out of the 8. It is of your choice. All are carrying equal marks. The best is start with the one you know best so that you get the energy to motivate you to move to the others. Begin with the one you know best and continue. Bearing in mind that each of them is going to carry equal marks. And 5 of them, the total mark here, it is marked out of 80, meaning 80 divided by 5, each of them is going for 16. Another hint you as learners should know, and you keep on practicing, is also that we have 2 hours and 15 minutes to do this number as any other papers. But this 2 hours and 15 minutes is having 135 minutes. 15 minutes is for your planning, as usual. The actual work is to take 2 hours, which is 120 minutes. Now, when you divide 120 minutes by 5, you will get 24. Meaning, you are supposed to work for 20 minutes so that you give that 4 minutes for you to check what you have done. Also, you should know that the questions that require you to describe an experiment, you are to use the soft languages. When we say 3 holes are made, it is like you are reporting what has already done, but instead you are the one who is describing that experiment to someone who doesn't know. So you use direct speech or direct statement. Make this, do that, do this, and we continue like that. So that is how to describe. And the description requires that there is something like a diagram that you have as a mental picture. That mental picture, either before talking about it or after talking about it, you need to put that mental picture into reality by drawing. So you either sketch or you draw the diagram, and when you are drawing the diagram, it should be a workable diagram that can at least portray something meaningful. So for calculation questions, also, you use the correct formula. Be straightforward. If it is the law, the statement of the law is always transformed into mathematical expression, and you need to put it down. And do not forget to include the units where the units should be there. Like question 1, we are talking of the A part of it, the definition of isotope, Roman number 1, and atomic number. In one way or the other, we have also tried to handle it in the past. Isotopes are atoms of the same element with the same atomic number, but different mass numbers, atomic mass, or the mass numbers. Meanwhile, atomic number is the number of protons in the nucleus of an atom. To some extent, you can also say atomic number is the number of electrons in a neutral atom. But normally, we talk of the number of protons in the nucleus. Because in a neutral atom, the number of protons equals to the number of electrons in the outer shells, outside the nucleus. So those are some of the definitions. And for the nature is, what is this alpha particle? What is this beta particle? What is this gamma rays? We know that alpha particles are helium atoms. These are helium atoms. So they are positively charged particles, but their nature is they are helium atoms. They portray the characteristic and the nature of helium as the chemical representation talks about. And the beta particles are negatively charged particles. These are electrons. These are electrons. Gamma, here we say gamma is a ray. Gamma is not normally regarded as a particle. Gamma is a ray. And is just a radiation, which has nothing to do with effect on the parent nucleus as far as the atomic number and the mass number is concerned, but it helps to stabilize. Like, for example, when I am annoyed, maybe I heard of the death of a relative, but I'm too annoyed. I begin by shedding tears. The annoyance brings me to shed tears. But when I shed the tears, however much you shed tears, your mass will not reduce. But you will only become stable after the release of these tears. So I compare the gamma rays almost like that in our everyday experience. Alpha particles in the, when we move to the B part 2, the sample of that, we move to the calculation, which is the D part here. Still, we can use this formula or we can use the other formula. The one that is very okay with you, the learner, is the one you take into consideration. But the best is you are in the school and you need to explore many avenues that can lead you to a shorter way of doing it. So you continue to master, but not to cram. There is no cramming in science, but there is mastery of it. So try to follow this, and we shall get there. Meanwhile, to use the division and subtraction part, that division part of it, you can also go through that first principle, but not using the formula as we have said earlier. So the medical use of radioactive materials, they are many, but we have given this one only to spearhead, but there are many. So it is a treatment of cancer, sterilizing medical equipments, detecting tumor in the brain, detecting diseases in the hidden organs like in the lungs, locating other materials that you might have swallowed so that they detect where they are, like maybe if you have swallowed or a person has swallowed safety pin. They are many, but what you bring here should be something related to the medical use of radioactivity, because we have very many uses of radioactivity, but here we are talking of only the medical use. In question 2, we are dealing with the cathode rays. We deal with the cathode rays, and these are streams of fast moving electrons, and properties, any two properties. Then as when you are told or you are instructed to give two properties, not to waste time, get the best two you know that you don't doubt and put them down. Don't try to test and say, I will give 4 or 5 or 6 because they will mark all of them and maybe they add on to my marks. That may not work. So they will get the first 2 and the rest feel like they have not seen. A well-leveled diagram of a CRO consists of the electron gun, the deflecting system, and the screen, the fluorescent screen. The electron gun, the components of the electron gun, much as we have the heater there, we need to have the cathode where electrons are generated, the grid where control is being made, and the anode to accelerate the positive potential part of the electron gun to accelerate. Giving it to the deflecting system starts with the Y nearer to the anode, the X almost towards the screen. So this one, the Y plate deflects the rays or the beam vertically on the screen. Meanwhile, the X plate here deflects the beam horizontally on the screen. The beam is, in fact, the tube is evacuated so that any molecule of air should not be there to interfere with the normal movement or the normal speed of the electrons that are accelerated to strike. Also, we have the coating that are there. We have some carbon coating inside in order to attract the stray electrons so that the experiment on the screen should not be tampered with, or you should not be confused. So when we continue, we see that the cathode is heated. That is when we are describing how it works. After drawing the diagram, how it works, the cathode is heated by the filament, and the electrons are boiled off the cathode. The electrons are accelerated through the anode, in fact, through the anode to the deflecting system, but the number of electrons that are accelerated to move through is controlled by the grid. The grid controls, because it is at a negative potential, tries to repel some of the electrons, and few electrons are allowed to move so that we get it on the screen. So the X plate and the Y plate deflect the fast moving electrons horizontally and vertically respectively, meaning the X plate horizontal, the Y plate vertical. So on striking the screen, they cause fluorescence on the screen. Fluorescence here means absorbing radiations of short wavelength and producing from there radiation of long wavelength. So that when these radiations they strike the screen, the short wavelength radiations are to be seen in form of light. So they generate a radiation of another longer wavelength, that is light, and that is why we see the brightness. So when we compare the radiations that are moving from the cathode through the anode to the screen, they have a bit shorter wavelength. That is why the fluorescent material makes it to be like that. Then when we move to the next part, uses of the CRO is to measure the voltage, to study the waveform, and there are others that can also be compared, but here we are restricted to have two, of which one of them, the applications are given down in the question C. When we try to see the type of waveform on the screen, as seen from the diagram, is generated by alternating current. So it is alternating current voltage, that is AC voltage, which is fed in. The amplitude is the same as the amplitude gain multiplied by the amplitude itself. The value, the voltage per amplitude or per meter or per centimeter in the amplitude. So that is why every 2 divisions or 1 division is 0.5. There we have 4 divisions, meaning we have 4 times 0.5, then times the voltage per centimeter, we have 10 volts. That is the voltage which is generated. Therefore, the peak to peak is twice that. The peak to peak voltage is twice the voltage generated. And that is 2 times 10, which is 20. Frequency is always got as a reciprocal of the gain in the time base. Therefore, it is 1 out of the time base gain is 5 times 10 raised to the power -3. So 1 out of that, the reciprocal is 25 hertz. And that is the frequency of the signal that has been sent into the CRO. Question 3 is talking about the radioisotope. And a radioisotope is an atom of an element that is unstable and can spontaneously disintegrate to form a stable nucleus with the release of radiations. And what are the industrial applications of this? Here we talk of the industrial application of radioactivity in general. So we have seen many here, may not stop here, but we need only 2 that are there according to the question. So any 2 of these is used to measure fluid flow in pipes, in industries, used to provide sources of energy, that is electricity, hardening of polythene and petroleum, used in food preservation, tracers in identifying oil leaks in oil pipes, and even in some tires and the rest of it, some leakages, imperfections that are there in some containers and other apparatus that are used. Used to measure the thickness of the metal sheet, used to, it is used as a level indicator, that is to check the filling packets of the soap, powder, and other materials of the same kind that require that. In the diagram in question 3b, we have the source of radiation, and in between there we have the cardboard. These radiations are directed to pass through the cardboard. Behind the cardboard we have aluminum sheet or foil. Behind that we have the lead sheet. So with the properties of these radiations from radioactive material, we'll find that alpha particles are stopped by some sheets of papers. Therefore, behind cardboard, there is no alpha particle. Between the cardboard and aluminum sheet, we have the beta particles and the gamma rays. After the aluminum sheet, because aluminum stops the beta particle and it is the gamma rays that move. And at the end of it all, the gamma rays are stopped by the lead sheet. So behind the lead sheet, there is no any other radiation. Members, when it comes to the graph or performing the graph, we borrow the leaf from the physics practical. We know in UNEP graph paper, we have 24 small divisions in the vertical axis. In fact, 24 centimeters in the vertical axis. But 1 centimeter equals to 5 small divisions, meaning we have 120 small divisions in the vertical and 100 small divisions in the horizontal. That one, we use it to get our scale that we are using to plot. But after plotting, the origin is there for the start of the radioactive nuclide. The original mass is there when the time is 0. At the start of timing, the original mass is there, and that is why we have on the vertical axis, we have a point where we start from. This is where the original mass is, and careful plotting and freehand drawing, we shall come up with this diagram or the graph. But this graph is not going to meet the time axis. It's not going to touch the time axis, because by the time the activity reduces before reaching 0, the element will have changed to another element of a different half-life and a different activity rate, which starts afresh on its own. So that's why the decay curve normally do not touch the horizontal axis. They do not touch the horizontal axis. After the freehand drawing, you divide the original value here by 2. Then you locate where it is on the vertical axis. You locate where that result is. Then you run through horizontally through the time axis, along the time axis, until when you meet the graph you have drawn. After you have made the graph you have drawn, drop it down to the time axis, then you read the time. That is the time which is equivalent to a half-life of that radioactive material. If you still have the doubt, you can also continue making a half of what is here, a half of a half, which comes to a quarter somewhere here, and again run through the time axis until you get the graph, the freehand drawn graph, or that line. Then run it down to read the time. Supposing this is T1 and the other second one is T2, then the half-life is T2 minus T1, which is also going to be the same as T1 minus T0, because this time is at the time, in fact, when the time is 0. So you can continue practicing that, give you chance, go nearer to someone who can help you in trying to choose the scale very fast, because for the scales of radioactive materials, we have big values or larger values in the vertical, larger values or in terms of the 10s, 20s, even 50s, or even 100, depending on the activity of these materials and the half-life. So be careful of that, and you try to do it. Keep on practicing, keep on practicing. Thank you. Question 4 is outside a bit. From the modern physics section we have been dealing with, and this one is picked from wave. And these are normally the areas, the modern physics and the wave, most of these areas that are neglected by the learners. And we encourage you to pick it up very seriously, because this is what is in the 21st century. We get them everywhere we are living and everywhere we are going. In the modern world, we deal with waves in one way or the other. We deal with modern physics in one way or the other. So all these two areas, we need to deal with them very well. So, Steve. Hello, Steve.
Yes.
Can
Teacher.
someone help?
Hello?
Yes, can someone help?
Okay, Teacher Peter.
My network is warning me.
Okay, Teacher Peter.
I will be online.
Okay. Teacher Peter, are you on? Okay. Just a minute. I want to see whether Teacher Peter is okay. Teacher Peter? Okay. It is fine. It is fine. Okay. 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 You can now stop the sharing.
Okay.
Okay. Yes, thank you so much, Mr. Mark Okum, for that. Now, allow me, we are going to share the questions again in the chat, but let me now first emphasize the very key points when it comes to paper 1 and paper 2. He has taken us through, but we wanted to show you how do you answer and which sections are very important, which numbers are not going to miss in any paper. So that is what he has been taking us through. But now I want to emphasize some of the key things that our learners, or some of the mistakes you students make whenever you are attempting paper 1 and paper 2. In other words, I'm going to look at what we call the do's and the don'ts. Which things are you supposed to work out and which things are not right when it comes to paper 1 and paper 2. So I want to share, just sorry about that. I think my screen has to be on now. Mr. Okumu, just confirm to me that you are able to see my screen. It's my screen. It is like a blackboard. Okay. Mr. Okumu, are you seeing? Members, hope my screen is on. So I'm going to look at the do's and the don'ts. And the first thing I want to look at, what I'm going to call the do's and the don'ts, whenever it comes to attempting the physics. So that is what we call the do's and the don'ts. The don'ts. When it comes to paper 1 and paper 2. The first one, I'm going to start with the definitions. When you look at paper 1 and paper 2, like it or not, 5% of the questions that are being said are about definitions. And you find that learners make mistakes whenever it comes to important definitions. If I can give you an example, the first example I want to use is the one of called velocity ratio. That question has appeared for many years, but still the learners are still failing. And why? It comes from the way we are defining what velocity ratio is. And how are the learners defining velocity ratio? You find that they are going to ask, what is velocity ratio? And what is velocity ratio? And what are the learners going to define? I'm going to just pull out some of the things that learners make. And the learner is going to say, these are the answers the learner is going to give. Is the ratio of effort distance to load distance. This is how learners define when it comes to velocity ratio. But I want to let you know that this is something they are going to cancel. And this is the mistake that you are making. Take an example. I'm going to use a simple seesaw. When you look at the seesaw, this is my seesaw. You know that on a seesaw, you have what you call the load and the effort. So when let me say, when there is a load this side, it means that you are going to apply an effort this side. So this is going to be my load, and now I'm applying the effort to the other side. In other words, when you sit this side, it means that your load is going to move like this, and your effort will move like this. So the distance you have from this pivot point, from this point here, up to here, is what we call the effort distance. The distance you have from this point, let me use another color. The distance you have, the distance you have from here up to where your load is what we call load distance. I want to let you know that this ratio you are talking about in your definition is not what we call the velocity ratio. When we talk about velocity ratio, we look at how the load and the efforts are moving, the distance they are taking. This distance that the load has moved from this position to this position is what we call the distance moved by the load. The distance moved by the effort from this point to this point is what you call the effort, the distance moved by the effort. And therefore, when you are defining what is velocity ratio, it means that you are going to define it as the ratio of the distance moved by the effort to the distance moved by the load. That's how we define, that is the correct definition of what we call velocity ratio. The moment you mention is the ratio of the effort distance to the load distance, you are going to fail it. The reason being that what you are defining has never been velocity ratio. So that is one of the mistakes that we make. Whenever learners see that question, they run very quickly to define it. At the end of the day, they end up failing it because they have defined it wrongly. However, on that same definition, there is a key word. Remember, when the effort, when you are moving, when the effort is moving, the load also moves. So when you are defining, do never forget that at the same time. That is now another keyword that we need to include. Whenever you are defining the velocity ratio, do not forget that keyword. You are going to say the proper definition is, this is the ratio of the distance moved by the effort to the distance moved by the load in the same time interval. There you are going to get a full mark, because now you know what you are talking about. The load and the effort move at the same time. So when you are defining, please, let's be very careful whenever we are defining key things in physics. Another key definition that I want to bring to your attention is going to be displacement. When they ask what is displacement, when we talk about displacement, we are looking at the distance that you move in a given direction. The moment you look at displacement, learners at times just define it as this is the distance you have moved. This is the distance moved, or this is the length between 2 points. That is not displacement. Displacement is a vector quantity, implying that when you are defining displacement, the key word being a vector quantity, the key word must bring in the word of the size, which is the length. It must bring in another word, which is the direction. So when you are defining what displacement is, you can say this is the distance moved in a specified direction. Distance is the scalar quantity. The direction you are moving is what gives us the vector. So displacement is a vector quantity. I can give you an example how we can distinguish between displacement and distance, such that when we are defining, we emphasize the physics, which is the direction and the size. Take an example. When you move from Kampala and you go to Jinja, let me say from Kampala to Jinja is 80 kilometers, and you move from Jinja to Kampala back. If they ask you what is the total distance that you have covered, your total distance will be 80 plus 80, which is 160 kilometers. However, when I'm looking at the displacement that this person is going to cover, displacement, I'm going to look at the direction. That when I'm moving from Kampala to Jinja, I'm taking the east direction. So when I'm moving the east, I can consider that to be a positive direction. When I'm coming from Jinja to Kampala, that is another direction. You have changed the direction, meaning that I've had on negative 80. The negative shows me the change in the direction, meaning that now my total displacement is going to be 0. This is what distinguishes what we call a vector and what we call a scalar quantity. Displacement being a vector quantity, we look at the direction that this person is moving. And therefore, when you are defining, please and please never forget the word direction, because it is key in the definition. The same thing will happen when it comes to velocity. When people are defining velocity, you have to know what is velocity. That velocity is a vector quantity. So when you are defining it, you can say that velocity is the rate of change, is the rate of change of displacement. This is very okay. Or you can say is the ratio of the distance moved, is the ratio of the distance moved to the time taken in a specified direction. The moment you mention the word distance, then accompany it with the direction. Because distance is a scalar, direction is a vector. But the moment you mention the word displacement and rate is already covering what you call the ratio, and it is already covering what we call the time. And displacement is what covers the vector concept of it. So those are some of the key things I wanted to bring out when it comes to definition, much as there are others that are supposed to come, but at least those ones are very common and we usually make mistakes. The same thing happens when you are defining diffusion. When you are looking at diffusion, you need to know that diffusion is the spreading of the molecules from the region of higher concentration to region of low concentration. Never make a mistake to say from low concentration to higher concentration, because always the particles move from the area where they are much concentrated to areas of low concentration. That is very key whenever we are defining. So take note of those ones and be very careful. Another definition I'm going to bring out is coming from heat, what we call the boiling point. When you are defining a boiling point, avoid repetition. Some of you define it as say boiling point is the point is the point at which saturated vapor pressure is equal to external pressure. Please, that is not correct. When we are talking about boiling point, never bring in the word is the point at which the saturated vapor. No. When you are defining what boiling point is, you have to say is the temperature. That is the key word. Is the temperature at which the saturated vapor pressure. So when you are defining boiling, you are looking at the temperature of the liquid that you are boiling. So meaning that when you are defining what boiling point is, avoid using the point. They ask you, what is boiling point? Is the point? No, it is the temperature. So that word is key. Is the temperature at which saturated vapor pressure is equal to the external pressure. If the same thing happens when they say, what is freezing? We know that freezing is a process. So the key word is the process. These are now I'm talking about heat. So you have to bring in that keyword is the process that occurs when a substance changes from a liquid to a solid at constant. Now, these are the keywords at constant temperature. These are the key marking words that they look out for. That when you are defining freezing, you say is the process and at which temperature? The temperature must be at constant temperature. So you may write the whole statement, but when you have not written the correct physics, so we need to look out for those keywords that I'm defining freezing. Then that means I must mention is the process at which or that occurs when a substance changes from changes from a liquid to a solid state. But if they say, what is a freezing point? Then when I talk about freezing and freezing point, those are two things that are different. Freezing point, I will now talk about the temperature. The same thing like I've been telling you when it comes to boiling point, you talk about the temperature. Freezing point, you're going to talk about the temperature at which a substance changes from a liquid to a solid state. The same thing happens when they ask, what is melting point? So still you start, is the temperature. Don't say, is the point. What is freezing point? Is the point. That is not correct. Say, is the temperature at which a substance changes from solid to a liquid. That's what we call a melting point. So that is briefly about what we call definitions. In case you have any question concerning definition, then kindly you place them in the chat. I'll have to look there and look at them. Number 2 is what you call the laws. I'm looking at the do's and the don'ts and where we lose marks. The next one is what we call laws. When it comes to the laws of physics, like when they tell you it is a law must not be broken. A law must be maintained. Do not create yours, do not change. That means that give it the way it is. When you look at laws, at times laws have what we call conditions. Example, provided no external force is applied. That is a condition of which we should not miss. So for whenever it comes to the laws, state them the way they are. Take an example. At times we may have state the law of electrostatics, state the law of charges. That is one of the laws that they usually state. State the law of charges. How do students write? They say it states that like charges repel, and like charges repel, and like charges attract. And this is where you are going to stop. Now, the moment you stop at this point, sorry. Okay. Sorry. Okay, I've lost my screen, but it's fine. Now I was talking about the like charges. So when you are defining, when you are stating the law, when you are talking about like charges, Then you say, like, this is what students say, like charges repel, unlike charges attract. Charges attract. This is okay, but this is not correct. Something is missing. So this is why you need to be very careful and say it states that like charges repel and unlike like charges repel and unlike charges, but what is missing is the word each other. The moment you have missed this word, then you have not written it correctly, because you know very well that whenever you have two charges, when I have a positive charge and I have a negative charge, the force between the two charges is an attraction force. That means that the positive charge will be attracted towards the negative charge. The positive charges will move towards the what? The negative charge. So these two charges are going to come together. They are going to attract, the force of attraction. So that means that the positive and negative charges attract each other. And in case these two charges that are of opposite charges, it means that there is going to be a repulsion. And this repulsion is what brings about what you call the neutral point. So here now, I expect you to know that if at all it is a negative charge, then don't forget the word each other. So when you are stating the law, say it states that like charges repel each other and unlike charges attract each other. That is the complete law. The moment you miss the word each other, then it means it ceases to be a law. Another one I'm going to talk about, so those are some of the common ones that where we make mistakes. You forget one word and you think you have passed, yet that one word is really costing you a lot. From that, I'm going to bring about formula for a calculations. I'm going now to talk about calculations. Now, when it comes to calculations, you're going to find that in case this paper one, you're going to find that the calculation takes a maximum. You never find most of the questions find they are taking 3 marks or 4 marks around this range, or at times they can take 2. There's no problem. They can say calculate the force, maybe acting on this. Now, when it comes to calculations, let us be very careful. Where are these marks awarded? One, the first thing you must have when it comes to calculation is what we call the correct formula. This is very key. In case the formula is about force, you are going to calculate force. Then you say force is equal to the mass times what? The acceleration. In case maybe it is it is Newton's laws, then you say V is equal to U plus AT. In case, so you must have a correct formula. The moment you have a correct formula, say force is equal to mass times maybe E. When your formula is correct, then the next thing we are going to look at is what we call substitution. Substitution. Here, a correct formula will give you, they'll award you a mark. Correct substitution awards you a mark. Then we shall look at the correct arithmetics. How is your arithmetics? The mathematics you are carrying on. You have seen people who write 20 out of 10, and the person puts for you 200. Is this mathematics correct? That no. Much as he may have substituted incorrectly, but when the arithmetics is not correct, then it means you are not going to get answers. And he comes down and puts the answers too. So now we need to be very careful. I've said correct formula, correct substitution, correct arithmetics, and then they consider correct answer. Now, when it comes to the answer, they are going to look at 2 things. One, they are going to look at the accuracy of your answer. And then 2, they are going to look at the units. For things that require units, you must include them because they can take correct answer and units. So this is where you must obtain the marks. In case it is a calculation, first summarize. Whenever you meet a number of calculations, summarize the variables you have. And then say, in case it is maybe about motion, first summarize that my A has been given as 2 meters per second squared. My velocity V has been given as 4 meters per second. What they want me to calculate maybe B. They want me to calculate A. Summarize your question. Afterwards, check out what is the correct formula that I must use. Then after you go to substitution, correct arithmetics, and then you go to the correct answer. These are where the marks are going to be coming from. So that's why when you check your paper, you'll find the teacher is putting a half, putting 1, depending on how the question has been said. Please and please, whenever you meet a calculation, first summarize to find out which variables you have, and then after you continue to obtain your answer. But do not forget that units are key for calculations. Units are key. When it is acceleration, notice meters per second squared. And please take note that we no longer use this kind of symbols. Yes, we always encourage our students to move from this side to this side, because this is much, much better. In case this velocity, we expect to say meters per second. So let's take note when it comes to the units. Another thing I'm going to talk about is what you call diagrams. When it comes to a diagram, it must be a working diagram. A working diagram means that what you have drawn can clearly be seen by the examiner. Someone marking your paper must be able to see everything you have mentioned. So anything you are going to mention in your explanation, in your procedure, let it be seen in your diagram. However, when it comes to diagram, like I've said, diagrams must be working diagrams. 2, after being working diagrams, 1, label it correctly. That is 2. 3, show your arrows. Let the arrows you have drawn, let them show that now this is where I have my stone. This is this. So that is what we call correct labeling. However, please take note that in case you don't know or you are not sure of that part, in case now, like the teacher were telling us about the cathode, in case you don't know about them, please do not commit yourself. Take an example. I want to just show you something here about the diagrams the teachers were drawing. Take an example. You have your tube here. In case you are not sure of the parts, don't commit yourself. You would rather leave it not labeled than you putting something wrong. Imagine now someone mentioned goes onto the screen and labels it wrongly. Then that means you are going to miss. Otherwise, if you are not sure, then leave it in case you are not sure of that part, leave it, other than committing yourself to something you are not sure, because it might change the meaning of what you are going to explain. 3, I want to take note that when it comes to the diagrams, questions are specific. Questions may tell you that with an aid of a diagram, with an aid of a labeled diagram. For such questions, please and please, you must draw that diagram. You must draw the diagram. For questions that ask you to use the diagram, you must, it is a must. And those diagrams, always ensure that you label at least 4 parts. 4 parts must be collectively labeled, because each of those parts may carry a half depending on the marking guide. So that means you have 1 mark or 1 mark. It depends on the marking guide, but each part will be given a mark. And if at all it is a diagram, look out for the key things on that diagram that you are going to accompany in your explanation. Those are the parts you must first label. leave along the minor parts that the diagram can work even without them. So those ones you can first ignore and look at the main parts of that given diagram that you are being asked to draw. But like I've said, it must be a working diagram. Then there are questions that they may ask you to describe an experiment. They can say, describe an experiment. For those ones, you may not draw the diagram. However, there are some diagrams that for them, you may not be able to bring out the explanation if that diagram is not, if that thing, if you have not what? Let me say, if you have not done it. I can give you an example. At times they may ask you, describe an experiment. Describe an experiment to determine the center of gravity of an irregular lamina. For such a question, the diagram is not required. Just explain how are you going to do it. So you can say 3 small holes are made of a well-spaced intervals around the edge of a regular. So you can explain, you can write the procedures without necessarily having a diagram. However, for experiments that require diagrams, please go and draw them. They can also ask you, describe an experiment to determine the acceleration due to gravity using a pendulum bob. Now, for such experiments, where they use, where they have told you to explain, then you have to say, a pendulum bob is fixed on one end of a string and then suspended on a retort stand. Then, in case they have asked you to use a diagram, then I think let me give an example on that one because it is really very key. Our question is saying, describe, describe an experiment to determine the acceleration using the label diagram. Describe an experiment to determine the acceleration due to gravity. Now, for such a question, please you draw your diagram and let your explanation be a working explanation. In case you mention about that a pendulum bob is fixed at one end, let that pendulum bob be seen that the pendulum bob is fixed at one end. This is the fixed end. Then mention that this is the fixed end and this is my pendulum bob. Now I'm describing what a working diagram means. So you say a pendulum bob is being seen, is fixed on one end of a string. Then you show that this is a string. So that is what you call a working diagram. Then you say the initial length of the string is measured using a meter rule. You can have your meter rule somewhere here that shows that you are using a working diagram. So that's what we call describing an experiment. The bob is displaced through a small angle and released. Is your diagram showing how your bob is being displaced? That this is our bob that is being displayed through a small angle. So that's what we call a working diagram. That let your diagram be a working diagram. In case here, you put even L. So this is what we call a working diagram. Anything you are mentioning within your explanation, let it be seen on your diagram. Don't mention things that someone, when he looks at your diagram, cannot be seen. That's what we call a working diagram. And in case it is something that can be done in the laboratory, then go on and show the table of results. Because, you know, when we go in the laboratory, we draw the table of results. After the table of results, we are going to go on and look at the graph. After the graph, we are going to go on and look at the slope. So when it comes to experiments, there are things that are expected. In case an experiment requires you to find a diagram, we shall expect you to have a diagram. We shall expect you to have the procedures, how that experiment is being carried out. We shall expect you to have the table of results. Talk about the table of results. That in our table of results, we shall include the values of T, values of L, like that. We shall expect you to talk about the graph, that a graph of this is plotted against this. And take note, we use the word against, that a graph of T squared is plotted against maybe L. Then continue and say that from the graph, the slope S is obtained using the formula. That is what we call a working diagram, a working experiment. For any of your experiment, have the diagram, have the procedures, have the table of results, have the graph and the slope. This one you may not draw the table of the results, which is ideal. You may show the table of results, or you can include a paragraph that says that a table of results is tabulated and values of V, L, C are included. A graph of T against L is plotted. These are the marking points someone is going to look out. Then at the end, after you stop, we shall expect to show the formula. In case this acceleration due to gravity, that is your experiment. Then we shall expect that at the end of the day, we are able to see that in order for you to obtain the acceleration due to gravity, the formula has been written. That my D can be obtained from 4 pi squared out of maybe S. In case S is what you call your slope. That's what we call a working experiment. And that's what we expect you now to write. Then, I know we are running out of time, but let me first hit on some key things before we leave. Another thing I'm going to talk about, I know you have questions, I'm going to look in the chat and then I'll sum them up at once. Another thing, before we leave that, I'm going to talk about what you call force diagrams. Like there are experiments, let me say experiments, or there are some diagrams where we have to use force diagrams, or there are some force diagrams that may be drawn and you may not need to draw a force diagram. When it comes to a force diagram, never forget the arrows. Arrows are key. Whenever it comes to force diagrams, please put an arrow. At times they may show you, let me say, they have given you 4 Newton force, maybe 3 Newton force. Show the arrow that this force is moving this side, this force is going where? Up. And therefore, I can obtain my magnitude. How? That this is my force, which is parallel, and therefore this is my magnitude. So for forces, or for diagrams that require force diagrams, then please, you need to show our direction. Then when it comes to questions that require calculating the cost, take an example in electricity. I want you to be very careful when it comes to units. Some questions, the question, because at the moment we are currently using UPX. So follow the question. What are they using in the questions? Are they using shillings or are they using UPX? Do not mix up the quantity or the units being accompanied with the money in case is a calculation. In case you find they are using UPX, maintain the UPX. Don't mix with the shillings, because you may find a question, some questions use this, other questions use. But at the moment, as a country, we are trying to adopt to UPX to show our country. So we need to be very careful when it comes to that. Then I'm going to talk about the symbols. Avoid using symbols that are not scientifically known. Take an example. At times they may tell you, calculate the density. Many of the learners are going to say density is D, that D is equal to mass out of volume. This is not the symbol for density. The symbol for density is given as rho. We write it like that scientifically, but it is given like this. This is the symbol for density, meaning that if you are not sure of that symbol, don't commit yourself to write D, because D is not a symbol for density. So for you, the moment you write D is equal to M out of V, someone may not understand that this is density. Someone may say this is D, maybe this is dense, this is what? So if you are not sure that this is what it represents, then write it as a full formula, that density is given by mass out of the volume. Write the whole formula, other than you committing yourself to writing something that you are not sure of. Avoid using D. D is not a symbol for density. The symbol for density is the law. And if at all you don't know it, how to write it, it is this symbol here. That's the one must be used. For questions, there are questions that require what, let me share another screen. There are questions that require describing. There are questions that require describing and explaining. One, for questions that require you to describe, explain, here is what you have to do. One, state your observation. State your observation. In other words, state what happens. What are you able to see? What do people see? And therefore, after stating your observation, that's what is going to help you to explain the physics concept behind it. Otherwise, if you don't explain your observation, then you cannot be able to explain or to write the physics behind it. So we need to be careful when it comes to such. A common example that they usually bring that requires you to explain comes from the pressure topic. At times they ask you, explain why one feels more pain when maybe an elephant or when a goat steps on this person other than maybe when an elephant. Why is an elephant able to walk on a soft ground, yet a goat cannot? What is your observation before you explain the physics? What happens before you explain the physics? So what do you see? One, in case, let me talk about a goat. Let me talk about a goat or an elephant. In your observation, what do you know? That an elephant, this is what we see, that an elephant has toes made of flat surface area. Now, what do we see is that the toes of an elephant are flat, meaning that their surface area is big. And when your surface area is big, it means that you exert less pressure on the ground. What about on the goat? On the goat has smaller toes, meaning that the area is small, meaning that much pressure is going to be exerted. You go back and say that pressure is given by force out of area. And you know that the relation in between here is an indirect proportion, or what we call an inverse proportion. Whenever the area is very small, meaning that the pressure you're going to exert is going to be very big. This is why now you're bringing the physics, that pressure is inversely proportional to area. Therefore, whenever the area is very small, the pressure being exerted is very big. This is the physics. Which keywords are we going to be looking out for? We are going to look at the physics as he explained about area, surface area. Has he mentioned the word pressure? These are the key marking points for such explanations. They ask you, why is it that when someone is pierced by a nail, feels less pain than when someone pierces this person with a needle? So the needle, you know that a needle has a smaller tip up here, which has a smaller surface area. And therefore, once the surface area is small, the pressure is big. While the nail, its surface area up here is big, meaning that when the area here is big, the pressure, when the area here is very big, that means that the pressure being exerted is small. Now, that's how we explain when it comes to observation or questions that you require to explain. So those are some of the key things. Okay, I think when it comes to paper 1 and paper 2, those are some of the key things I wanted to mention, such that we do not make those mistakes, those small mistakes. Then let me take you to the dynamics. When it comes to physics, physics is an easy paper to pass, but we must be strategic on how to pass it. When it comes to 5-3, when it comes to paper 1, 5-3-5-1, we have 5-3-5-2, and we have 5-3-5-3, or 4, depending on what your school does. What do you need to know? That paper 1 will be out of 80. This one is 80. This one is 40. What do you need to know? What I need to know is which paper should I maximize? When you look at the recent UNEB questions, you are going to notice that mechanics is covering the biggest percentage. Mechanics is covering the biggest percentage from where the UNEB is setting from. After mechanics, other topics will come in later. Meaning that if you want to obtain a D1 in physics, be strategic. In paper 1, out of 80, get a minimum of 60. A minimum of 60 means that when it comes to section A, objectives, have your 25 at least. Objectives passed out of the 40. When it comes to section B, this is now where you need, because those questions are direct, a short response. You may not need to think a lot, but you just need to give your answer. Meaning that when it comes to this part of section B, I want you to maximize. To maximize. If you are to get a what? A 60 in that paper. Meaning that in this paper, when it comes to section B, at least make sure you obtain the maximum. And what is going to be that maximum? It's going to be 35. In case this can work for you. This is the 25, 20, 35. In what? In section B. In case this option is not working, then make sure you get a 30 in section A, get a 30 in section B out of 40. In case that option is not working out, then make sure that at least get a 38 here and then leave some few in section A. If not, the best section to work on, make sure you get 35 in section A. Then come in section B, look for your 20, 25. By doing so, you are already making an A. When it comes to paper 2, I want to assure you, 2 numbers are going to be from mechanics. 2 numbers are from mechanics. They can be 2 or more than that, but at least 2 numbers have to come from mechanics. When you look at mechanics, look at those things you covered in senior 1, senior 2, mainly. That's what schools have been doing. Mechanics, look at things concerning pressure. Look at things concerning forces. Go look at the introductory part. Look at those things. That is what you call mechanics. You'll find that 2 numbers are from there. If you have read your mechanics very well, meaning that you have at least 15 and 15, which is already 30. We have been discussing modern physics. Modern physics is a must-come number. Know that I'm going to do modern, at least I get also 15. Add your 15 onto this. This you have already done 3 numbers. And how many numbers does the paper need you to do? They need you to do about 5. What are you going to do? You add, this is already 45. Then say, what is remaining? I want to get another 60 or above. I have 2 more numbers to go. In those 2 more numbers that are remaining, make sure you score at least a 10 and a 10. Assuming that those numbers have punctuations that you are not sure of, but we cannot guarantee that you have a 15 here, 15 here. You may make some small errors, but get a 10 and a 10, add it here. What is that? You're already in 65. This is already 65 out of 8. Then your task, come to the last paper, paper 3 or paper 4, maximize. Say, in this paper out of the 40, can you fail to get 35? That is paper 3. When you have 60 out of 80, and you have the other 65 out of 8, and you have a 35 out of 40, you are already swinging in a distinction. That is already in a distinction. You want to get a better, this is what we call a distinction in physics. You can continue and say, let me get a 75 out of 80, 75 out of 80, get 35 or 40 out of 40. Here you are getting a pure distinction, 1. But here I'm putting other factors remaining constant. So if we are to get a distinction in physics, kindly ensure that in each paper you are working on, you get a minimum of 60. But here I'm talking about a minimum of 60. But someone who gets 60 is capable of getting a 70 out of 80. By doing so, we have a distinction already moving. This is what we call a distinction in physics. For you, move like that. Say here, the minimum should be 60. Here, 65. Here, a 35. And you have your distinction. Make sure that in paper 3, whether it is getting 40, get 40 out of 40. Do not wait. It is possible and you can. That's how we are going to get. And what is the formula for finding this? Today, I have not come, but let me stop sharing this and I show you a sample of what we have to do when it comes to a distinction in physics. When it comes to paper 2, I don't know whether I have my papers here. Sorry, let me see whether I have those papers. Sorry. Oh, unfortunately, I think I've crossed them. But give me a minute and I show you what it means when it comes to a distinction. You don't need, because I know that physics, it may not be friendly to each and everyone. You may miss out some key things because of here and here. Then what are you going to do? Now, for cases where you are struggling with some key things, then it means now for you, the first key thing you are going to master are what you call the definitions. Hope we are together. So the first key things, what you are going to master is going to be your definitions. When you look at these papers, you'll find that definitions and laws are carrying a lot of marks. This is one of the sample papers. You are going to find that only definitions, if we are to look at definitions and laws, 41 part A is a law, part 2 is a definition. Those are already 3 marks. Come. Number 43 is a definition. Those are 4 marks. Number 5 is a definition. 5, 6, 7, 8, 9. Come. These are 10. Already 10. These are 11. In other words, if you master your definitions, you go in the paper. In fact, I want to let you know, once you master your definitions in physics, you have mastered your laws, you can never get an F9 in physics. You can never, and it can never happen. As long as you know your definitions, you know your laws. Those are key things. Then here you're going to add on explanations. And then come maximize. Now I'm talking about someone who is not doing perfect in physics. For you, what do you need to do? Remember, if these papers are out of 8 out of 8 out of 40, I want to let you know, if you never want to see an F9 anywhere, in fact, I don't even want to talk about F9, make sure in practicals, you get that out of 40. Make sure when it comes to practicals, get 30 out of 40. Here you have maximized. Once you have 30 out of 40 in practicals, that is paper 3. In paper 2 and paper 1, get your 20 out of 80. Come here, get your 15 out of 80. Here, go. I want to let you know, you can never have an F9. If things don't work out, the least you can ever obtain is a pass 7. Once you have 20 out of 80, 15 out of 80, 30 out of 40, here you're already swimming in your pass 7. But here, I'm only talking about your 20 is coming from objectives that you have guessed, in case you are not so good in physics, of which I know, if you work hard, you can obtain a 30 out of 80. You can obtain a 20 here out of 80. So please, I want to let you know, physics is not hard. Physics is application. Let us concentrate You may not necessarily read everything you have in physics because it is wide. You may not, but concentrate. Know that practical and maximizing. Paper 2 and paper 1, these are the key things. So in practical, I've not talked anything because that is the session that is coming. I will be sharing how are we going to do in practicals to obtain 40 out of 40. This is very possible. And if you have never gotten a 40, then you'll be around the next session we shall have. We shall discuss the key things in section. But I've said, when it comes to paper 2, I want you to master experiments that teachers have given you. Master those experiments. Master your definitions very well. Master the laws. I want to let you know, once you master the experiments, you have mastered the definitions and the laws. Here, you are already having a credit and above. For distinctions, I don't undo all the calculations. We shall be good to go. So that is briefly about paper 1 and paper 2. Do not guess things work out, because for objectives, one of the mistakes that students are doing, for you to guess, you close your eyes and say, look at the options I have, which one is correct? Such things do not work out in physics at times. Some numbers may require you to what? To calculate. For those ones, go on and calculate. Please, I want to repeat myself, make sure you have mastered your mechanics very well. This is for paper 2. Your teachers will tell you what is in mechanics, those calculations, laws. Go on, master your modern physics, and then lastly, add on waves. Then other topics can come on that are easy for you to understand. Things like electricity can come in, things like electrostatics can come in, and then other parts can follow after. So briefly, that is paper 2, paper 1. So that is briefly. Allow me to look in the chat and I see whether there are some key things. Yes, Mr. Enima, that is very correct. Out of 60, that is the practical. Okay. I think that is enough. That is enough for today. So in case of any questions, kindly we shall talk about it later. But I want to explain that please let's maximize. We shall talk about practicals next time and the key things we need in practicals. Otherwise, we want to thank you so much for your time, and we shall talk about everything concerning the practicals, how to do them, and even how to look for the scale being one of the key things next time. Thank you so much, and I want to wish you a good evening. You can switch on your cameras, and then we have a small photo. Feel free to switch on your camera, and in case of anything, okay, so tomorrow we shall have the geography one, and we shall start on time. So please come on time for geography. Come on time for geography, and then we shall start from there. And then I will also throw more light about the 60%, the new change on that practical. Yes, because if at all you have looked at well, UNEP papers, you'll find them putting it out of 40, but it comes in calculations. Otherwise, have a good evening and bye-bye, everyone.